Welcome, everyone. My name is Nathan Heston, and I'm joined by my colleague, Daniel Moyer, and we're excited to be introducing to you today a training on the new Stackable SimpiPhi 6.6 battery. So welcome. This is not a NABCEP training, but we do have a lot of great content in here. Daniel and I are excited to talk to you about our latest product. And wanted to encourage you at the beginning here to use the question and answer. So there's a Q&A, should be a Q&A on your Zoom menu. Daniel, just a heads up, I'm having trouble seeing the Zoom menu on my side of things. So if we do get questions, please interrupt and we'll be happy to answer them as they come in.
Of course.
So welcome, everyone. So Daniel, why don't you start us off here by just talking about the MREA. I know we're going to have a presence there, and if you're interested in seeing this battery or some of our products in person, please consider joining us at one of these in-person sessions. So Daniel?
Yeah, thank you, Nathan. So this is one of the, I would consider old school kind of a solar festivals more than it's not your RE+, it's not your SPI. This is going to be out in the sun, out in the dirt, in Custer, Wisconsin, coming up in June. And if you want to join, there's a QR code there on the screen. Go ahead and scan that. And absolutely right, Nathan, we're going to have our new battery out there as well as some of our other products. So
you'll have a solar 15K there as well, right?
Yeah, and part trade show, educational event, and part grassroots festival. So excited to be there.
This looks great, and one of the things I like about these kind of festivals / shows is there's a lot of interactivity. And so yes, we will have a booth there. We will, have presence there as well as demo equipment, but there will be a lot of other installers that you can interact with, etc. So if you are in the Midwest, consider going to that. If you're interested in in-person trainings, I've shown a picture on the left side of a training wall that we have that we take around. There's a trailer there are a number of trailers that we travel around with and do demos on how to install, how to utilize our equipment, how to integrate it with things like our generators, or talk to you about how to use our equipment with Solarcs. And so if you're interested in in-person training, we're going to be having an installer event in my town, San Luis Obispo, California, on June the 6th, where we'll be training on our new 6.6 kilowatt hour battery, the one we're going to go through today. So if you want to see this in person, please consider coming to that training on the 6th. And if you are in the Columbus, Ohio area or the Ohio area, I will be coming to Columbus with this training. We'll be doing a generator training there, in addition to an energy storage training day on June the 13th. So do consider, if you want to see this in person, get your hands on some of the equipment, consider joining us in one of these in-person events. So what we're going to be getting into today, we're going to be focusing on the latest battery offering that we have. It is a battery with a number of options. It's a very quick install. I did one last night. It took about 15 minutes to do the install. Now, it's not entirely fair because I've done one before, but it is a very quick install. And it's got options for floor mount, wall mount. We've got some very interesting technology here that we've been developing, and we're excited to be releasing it to you. So you can see this stackable battery on the right side of the screen, and what you're seeing is three 6.6 modules totaling just about 20 kilowatt hours of storage there. 19.95 kilowatt hours of storage. And one of the things that we've done with this is introduce this rapid stack technology. There's truly no wires here. Truly no wires, truly no dip switches, very easy to install and commission this thing. I've commissioned one of these units just recently. Did a few commissionings yesterday in 60 seconds. Now, I don't expect it to take that long or that short of a period for you. It would probably take a little longer because you're going to be doing settings, but this is a very quick install, very quick commissioning. So the wall mount option is a very nice feature here. We have pairing with this inverter with Solarc inverters, or sorry, pairing of this battery of Solarc inverters, as well as our SimpiPhi inverters. So you're going to see some examples of that. But here's what makes this battery so different. we're looking at a battery that can be installed quickly, and all of the communication, all of the power is being transmitted through the stack, through this rapid stack connector technology that we've developed. It's an outdoor rated system. This is a battery that can be installed outdoors, waterproof. This can be done very quickly. There are no hidden wires here. So it is truly a wireless battery, with the exception of your home runs, to provide that power and the communication between the equipment. So this is one of the reasons why it goes by so quickly. Your installation goes by so quickly. We've also been quite aggressive on price. And one of the things I like about this battery is just the aesthetics.
Yeah.
Daniel, you want to talk for a little bit about the battery? And of course, we've got a new look to our inverter as well.
Yeah, thank you, Nathan. So we had shown in those previous pictures a stack of 3, which is great because this new battery has a very rapid discharge rate. We're going to talk about those exact specs coming up, but the idea that it has the amount of power, right, in watts that can handle whatever a Solark 15K may require. Now, you don't necessarily need that much energy, right? You can also use a stack of 2, which pairs perfectly with the Solark 12K. And then additionally, you could even use just one battery module, and that would be perfectly acceptable to pair with our inverter as well.
So here's a couple of looks of what this stack looks like paired with Solark 15K. So you can see it on the left side of your screen. As noted, it's an outdoor rated battery. The conduit here is a rendering. You probably want to use at least 1.5-inch conduit if you're doing this outside, and you'll want to use either a rigid connection or seal tight, obviously, to prevent water from getting into that conduit. But you've got a very nice pairing there. A stack of 3 batteries, as Daniel just mentioned, provides 14 kilowatts of power, which can meet that 12 kilowatts of power that a Solark, the maximum amount of Solark, can pull from batteries. And so a single stack here is a very nice pairing with a Solark 15K. But keep in mind that Solark and Briggs & Stratton offer smaller inverters as well. We have our 6K inverter, which pairs nicely with this battery. Communications are integrated. And a single one of these batteries has the output power, 6.6 kilowatts of output power, to power our 6 kilowatt inverter.
And Nathan, I want to just take a minute to talk about Briggs & Stratton as a brand. Briggs & Stratton is a 115-year-old company. We have a long history of working in the power industry. Millions of small engines we make every year still. We make mini generators. But Briggs & Stratton has now been able to offer these energy storage products. We have an amazing tech support team, an amazing warranty that's backed by a company that's been around longer than their warranty period is. Can't say the same true about all the other companies out there. By now partnering with Solark, we're providing solutions from 2 American companies.
Yeah, I like that. Solark, based here in Texas. Briggs & Stratton, of course, headquartered in Wauwatosa, Wisconsin. We're 2 American companies, and if you're interested in learning more about the Solarks, we're doing joint webinars together with Solark. So Solark will be joining me on a webinar on the 30th, talking about leveraging communications between our batteries and their inverters. I do want to highlight as we get started here, and bear with us, we're certainly going to get into the meat of and the specifications of this battery, which you're quite interested in, I'm sure. I do want to highlight, though, that we still have a full lineup of other batteries as well. Our 5 batteries aren't going anywhere. Those 5 batteries made out here in Oxnard, California, are several hundred thousand of these batteries probably out in the field, right? And these batteries are powering a lot of homes, backing up a lot of equipment, many of them in my town, many installations of these batteries in my town. So we will continue to make these batteries qualify for SCHIP. If you're a California-based installer, you can get an extra 20% off by filling out that self-generation incentive program paperwork. The Amplify batteries as well. These 4.98 kilowatt hour batteries, those are outdoor rated wall hung batteries, and those are also made here in Oxnard, California. We're going to be focusing today, of course, on our 6.6 kilowatt hour battery, the stackable battery on the right side of the screen, but I do want to highlight those other batteries in case you're interested. And the Phi and the SimpiPhi batteries, of course, fit into our outdoor rated NEMA 3R enclosures. These enclosures have the option for integrated heating that we talk about in some of our other trainings. And if that's something you're interested in, do still consider the SimpiPhi and the Phi batteries for some of your applications. Oops, didn't mean to skip over this. And I'd like to let Daniel talk just for a second about the Briggs & Stratton generator lineup that we have that integrates well with our
thank you.
as well as SolArcs.
Yeah, thank you, Nathan. And I had just attended a recent training done by John Cromer at SolArc about integrating generators into the SolArc. And the SolArc is really one of the top leading inverter brands, transformerless hybrid inverter brands that can absolutely leverage the capabilities of a generator. And somebody like me who's come from kind of the off-grid industry, generators have always played a part in off-grid systems. And now increasingly, I see them playing a part in on-grid systems. Perhaps a customer already has a generator. We can now add energy storage to the system, run the generator at its most fuel efficient point, save runtime by running the generator, charge up the batteries, and then shut the generator off. Our inverter and the SolArc inverter knows the state of charge of the batteries and can send a 2-wire signal to start up and shut off that generator. What you're seeing here is our air-cooled line on the left there. Those are not only considered standby generators, but they're also warranted for off-grid use or prime power use. We, of course, do make larger commercial ones. NG Max is a new technology we just came out with. What that allows is that if you run a generator on, say, natural gas, it usually derates. So if you hear somebody saying, I got a 22K generator, that's 22K on propane. When you go to run it on natural gas, it's maybe 18.5, for example. So by optimizing the intake manifold, the exhaust manifold, and adjusting the ignition timing, we're able to offer that 20K or 22K, whether it's on propane or natural gas. Additionally, we do make a lineup of whole home transfer switches. Now, imagine you got a SolArc 15K or even one of our inverters that has a generator input. Great, land the generator there. But if you're really trying to have a whole home generator, transfer switches in certain applications can be leveraged where you could potentially even use the grid port to land a generator. And SolArc, check out SolArc University. They got some great talks about this on how to leverage generators on these systems. Thank you, Nathan.
Thanks, Daniel. Yeah, and one of the reasons why we highlight these generators is, certainly there are advantages to generators for backup power and advantages to batteries for backup power, right? With batteries, you've got this seamless transition from grid power to battery power. With generators, of course, you've got that delay as the generator gets started up and the signal gets qualified. But of course, with generators, you've got that almost unlimited runtime in a grid outage. And with batteries, you have limited capacity based on cost. So by integrating two of these together in a system, you can leverage kind of the advantages of both. Okay, so I'm highlighting a stack of these batteries. Each battery needs to have a base. And there is some communicating equipment in that base. So we do need to have the battery modules on a base, and then they have to have a controller on the top. But we can have combinations where we just have one 6.6 battery to give you 6.65 kilowatt hours of storage, 6.65 kilowatts of power output. Or we could do a couple of batteries, and that will increase both the power output as well as the capacity, of course, of the battery. And so 1, 2, or 3 batteries could make up a stack. You need one controller, one base, and then 1, 2, or 3 batteries to make a stack. But if you have a bigger system, we've got systems where you quoted 4 of these stacks, right? You have a large house, you want to back the whole house up, you want days of run time. You can do six of these stacks, right? Up to 6 of these stacks for 120 kilowatt hours of capacity. Give you an idea, a Tesla Powerwall 3 is 13.5, I believe, right? Yeah. And so these are large battery backup systems. And I think that's one of our advantages over Tesla. You look at Tesla, and they did come out with the Powerwall 3. It does have some specifications that make it comparable to a Solarc 15K. But you're limited, right? To you buy that Tesla Powerwall 3, you're limited to 13 kilowatt hours of storage. And they've said they're going to come out with, additional battery modules. But they're not out on the market yet, right? And so I do think there's an advantage there, is the flexibility in the size of the battery storage system you can install. Additional advantage here is that we've got quite the high power output capacity of this. So just a single 20 kilowatt hour stack can deliver that full capacity to a Solarc 15K. And of course, you can parallel the stacks. You can parallel the Solarc 15Ks. So jumping into the specifications of this battery, what we're showing you here are some of the dimensions. Of course, we have the UL certifications, the 9540 edition 3, right? We have the 9540A testing, UL 1973, UN 38.3 for transportation. Looking down at the bottom of the slide here, we're showing you the surge capabilities of stacks of these batteries. So a single 3 stack of batteries can surge up to 17.5 kilowatts of power output, right? 10 seconds there. Meet those demands that you might have if you've got large equipment starting off of battery backup. Discharge rates are there. You might notice that we're at a 1C rate on the batteries. The batteries themselves, the modules themselves, have a 1C rate charge discharge. There's a little bit of a derating of that once we integrate those into a full stack. And that comes from the fact that we need to keep the modules balanced, make sure that the top module is not doing more of the work than the middle or the bottom module. But still, you're looking at a 0.7 C rate. That's very, very fast. What that means is you can discharge this battery in about an hour and 20 minutes, an hour and 25 minutes. So 0.7 C is quite a fast power output. The nominal voltage here, that's the battery's voltage at a 50% state of charge. This is consistent with LFP cells of 51.2. The voltage range of the battery is specified there, as well as the continuous discharge current maximums for a single module. So these modules are capable of a 1C power output. We do recommend a maximum charging current of 100 amps DC, and that's for longevity, right? We could charge a little bit faster, but if we try to charge too fast, we notice that it will limit the lifetime a little bit. And so 100 amp DC on the module for the charging side of things. The rated capacity is 6.656 watt hours. So there's a lot of energy there, and it's a pretty compact battery, about 7 inches deep, 17 inches tall, and just a little over 2 feet wide, 28.5 inches wide there. So round trip efficiency. Daniel, you want to talk just for a second about round trip efficiency here and some of the things to consider?
Yeah, of course. So one thing when we're talking about round trip efficiency, maybe we're talking about the battery itself and not the system level. So the round trip efficiency of just the battery, right? You put some DC in and take some DC energy out. That's really highly dependent upon the rate at which you charge or discharge the battery, potentially the temperature as well. But what we see, right, the advantage are DC coupled systems. And when you start to look at AC coupled systems, that you're really having that second inverse. So every time you have to switch from DC to AC or AC to DC, you're losing something. And that brings me up. We had a kind of a question, Nathan. Somebody had kind of corrected us, on the Tesla Powerwall 3, actually, you can have up to 4 modules. So you can kind of scale them up. Again, you might be limited by the NFPA rules about how many energy you can put in a certain garage or on the outside of the house, but absolutely you can scale up. And one thing we noticed about the Powerwall 3,
you can scale up. And in fact, just this last weekend, I was at my brother's house, and his father-in-law had 2 Powerwall 2s there, right? But my point with that is that with our batteries, you can do just battery modules. And I know Powerwall 3, they are coming out with, I feel like they're following us into the LFP technologies.
And DC coupling, Nathan, and that was going to be my next point, is that everybody's starting to see the advantage of not only the LFP like you just mentioned, but also the ability for DC coupling. Why? Because the round trip efficiency of a battery is probably equal across a lot of us, but it's the system efficiency that we're really looking at.
Exactly. You know, when you look at AC coupled systems, you take an N-phase system, for instance, and an AC coupled N-phase battery, you are losing that additional percentage for that additional change from AC to DC, DC back to AC, etc. And so making that extra change. So yes, Tesla has switched to DC coupled, and they are switching to LFP chemistry, which I think is a good thing from Tesla. I'm just pointing out that those extra battery modules that they're promising aren't there on the market yet. So I'm not trying to denigrate Tesla. I think they also make a good product. I also want to highlight something else.
You can absolutely, you could absolutely AC couple in a solar arc, right? It's not like you can't do it. And there's many reasons to do that. You come out to an existing site and they already have solar. Nathan, we have a question.
Sure.
Can our batteries sit at 100% state of charge for long periods of time, or do they need to be cycled? Thinking about purely a battery backup scenarios. That's from Jeff. Thank you, Jeff.
Jeff, that's a great question. In fact, we've been working on some training. Yes, they absolutely can sit at high states of charge, and there's no problem with that. In fact, we have a mode in our inverter that's battery backup. So it's grid tied backup, and the battery will stay charged. It'll sit at 100% state of charge, just waiting for that grid outage. So basically doing a function similar to a generator. You're not really cycling that battery. The important thing is that you don't let that battery sit at a voltage above our recommendation, right? So you don't want that battery sitting at 58 volts for a long time. You know, our recommended float charge is 54 volts. And so if you're sitting at 54 volts, you're not going to have damage to that battery. In fact, you know, we even recommend this as one of our operating modes. So that's a great question. Just make sure you're following the recommended float voltages for a battery backup system. Yep. And there are plenty of customers. The nice thing about doing a battery backup system is you could always install the solar later, you know, if the budget's not there for it. And as Daniel mentioned, you know, with AC coupling, you absolutely can do AC coupling, and there are plenty of cases in which you might want to. Let me highlight one more thing on this slide, and that's just this charging temperature window, the discharging temperature window. So I meant to get this in degrees Fahrenheit on here, and I'm just going to give it to you. You know, -10 Celsius is 14 degrees Fahrenheit. So by changing this electrolyte in this battery, we are able to charge down to 14 degrees Fahrenheit. That means if it's a cold morning, 14 degrees Fahrenheit inside the battery, right? The battery temperature is normally above ambient temperature. We can still charge. We charge at a C/5 rate, which means that you're not wasting time waiting for the battery to heat up before you start taking that solar energy in and start charging that battery up. On the higher side as well, we're able to, you know, this is a pretty broad temperature window for charging, up to 50 degrees Celsius. And there's protections built in to the battery to keep it safe, of course, in low temperatures and high temperatures. So if you go below 14 degrees Fahrenheit, it will restrict you from charging to keep that battery safe. The controller here, we're looking at the very top of the battery. We need one controller at the top. This controller is what allows the battery aggregation. It's what communicates with the computers inside each of the battery modules, keeps the system operating properly. This is where you will make your final connection. So you don't have to connect anything with wires or cables, with the exception of this controller, to connect the power cabling to your inverter and your communication cabling to our gateway. So this is what a stack consists of: battery modules in the middle, a base at the bottom. Now there's some options. We're going to get into those options, either a wall mount or a floor mount base, and then a controller at the top. Highlight the weight of that battery just for a second. It's quite nicely sized. If we went with a 10 kilowatt hour battery, for instance, and just a 1 stack or a 2 stack, you'd be looking at a battery that's almost unmanageable for 2 people. You have 10 kilowatt hour battery. If you've installed them before, you're looking at 250 pounds. This one's 140 pounds. And I have built a stack of 3 of these batteries myself. Certainly challenging to get that top one on. But at 140 pounds, 2 people can very easily assemble this stack. So the required components, you do need to choose one type of base. Obviously, you need the battery modules themselves and a controller at the top. To utilize DC power for a home, of course, you'll need an inverter. And the gateway that's shown there, E on the right side of the screen, that gateway is what allows us to do over-the-air firmware updates. It allows us to be able to let you monitor your batteries in our Energy Track app. And if you haven't utilized Energy Track yet, you'll see some screenshots of that in a little bit later. And then highlighting, of course, our Briggs & Stratton 6 kilowatt hybrid inverter there. What's a hybrid inverter, Daniel?
It used to be we'd have all these different parts and pieces. We'd have an inverter charger, a charge controller, automatic generator start, maybe a Mate 3 kind of monitoring system. A hybrid inverter took all those parts and pieces, put it into one box, right? The transfer switch is built in there, and it's really kind of an innovative way to do it. Puts a lot of those parts and pieces. Nathan, I'm going to take this opportunity. Somebody had a question. So for a small off-grid system located outdoor and with some other solar that will eventually be expanded and grid-tied, other than the battery stack, the Briggs & Stratton inverter breaker boxes, what other equipment is necessary?
Yeah, so that's a great question. And I was trying to get at it with Daniel there and asking what that hybrid inverter is, right?
It's there. Almost everything is there you need, right? The charge controllers.
Exactly. Right. So the nice thing about this inverter is it takes almost everything in. Solar comes into this. It's got an integrated rapid shutdown.
Yeah.
It's got an integrated a transmitter, right? We have an AP Smart transmitter built in to send that keep alive signal. The solar can come into this, land on it. It's got integrated automatic generator start. It's got the ability to take generator power in through a generator port. Your utility connection will come into this inverter. And of course, the output of this inverter is for your backed up loads. It's got the transfer switch built in so that you can pass grid power through the hybrid inverter. So what parts do you need for your off-grid system? So if you are doing a roof mount solar array, you'll of course want to have that roof mount have the rapid shutdowns there. Depending on where you were located, if you have lots of shading, you might consider using optimizers on your system. But with the exception of the battery and the inverter and the solar, obviously, you'll need that backed up loads panel, but that's about it. That gateway there will allow you to monitor your system remotely. You'll, of course, need an internet connection to
maybe a generator
and take use. And yes, if you're off grid, but for many of those grid tied systems like the one that Jeff asked about there, you don't need to have that generator. So it's a fairly simple startup. And as Daniel mentioned, it used to be all these things were separate. You'd have a separate charge controller. You'd have a separate inverter. You would have the separate transfer switches. And much of that is built into a hybrid inverter. So let's highlight some of the features of this battery. There's some things I really like about this battery. So each individual battery module has got an LED indicator light on it. And that indicator light tells you, hey, the battery's there, it's working, and there are no issues with it. If it might be going through something like a firmware update, that battery, the status LED on the battery module will be blinking at you, letting you know that that battery is going through an update. The controller on the very top, what you're seeing, that status indicator there, those LEDs that are there at the very top, that's like a fuel gauge to you. It tells you without looking at the app, right, that the battery, is at 100% state of charge, or maybe 3 out of 4 of those is lit up, and you know that you're somewhere between 75 and 100% state. If it's in a state of charge, it will be the light will be blinking, indicating to you that the battery's charging. The power button is right under those status indicators, and you use that button to turn on or off the DC power coming out of that controller. Rapid stack connector here is what we are leveraging to be able to make this stackable battery so easy to install. That rapid stack includes power cabling from and balancing balancing equipment. Balancing wiring, as well as the communications wiring. It's all done by just stacking those batteries. And then there are alignment tabs for when you're putting this together to make it very easy to install. So a lot of features, a lot of thought has gone into making this battery easy to install, and very aesthetic as well. It's quite a nice looking battery. Daniel, for those on this call that are looking at installing this battery on homes, let's remind them of some of the recommendations and limitations and code around installing battery systems in homes.
Yeah, so one of the biggest ones is the limitation on how many kilowatt hours or how much energy can you store in any one spot, right? A lot of people like to put these units in the garage, right? And this is a great slide from Mayfield Renewables. Awesome training programs. Check them out if you're interested. But really, you can do 80 kilowatt hours in a garage. On an outside of the wall, there is going to be some changes coming up that allows you to do more than that, and up to 600 kilowatt hours coming up soon. But really what we're showing here is 80 kilowatt hours on the exterior, and then 3 feet minimum between the units. Now, on the next slide, Nathan, I want to talk a little bit more about codes. There's we've always been looking at the electrical code, right? We're always getting out the electrical code, and we never really had to worry about building codes, right? What did we have to worry about with building codes was maybe having a 3-foot fire path on the roof for the firefighters, maybe the wind load on the solar panels. But now that we've introduced energy storage, there's a lot more building codes that are starting to take effect. For example, parking bollards, heat detectors, not smoke alarms, but heat
Are
detectors.
heat detectors needed for our batteries, Daniel?
If they are inside a garage or another enclosed space. And I would also mention, I got a class coming up on this. There's a difference between a heat detector and a heat alarm, right? A heat detector is usually part of a larger alarm system, whereas a heat alarm, and I will stay tuned for this upcoming training, are interconnected, right? So they have to be interconnected with the other smoke alarms in the house. Drywall, where do you need to have drywall, right? And if it's in an enclosed room, like a laundry room or a basement, that essentially the entire room has to have sheetrock that is 5/8 inch, right? They call it X rock, that has a fire rating. If it's in a garage, and it's kind of a wild west when it comes around with drywall. What the code says is that you have to have drywall between the living space and the garage, which is usually already there. And potentially, if you have a bedroom above the garage, you're going to have drywall there. Does the entire garage need to be drywalled? Jeff Spees said it in one of the CALSAs. Nobody really knows, but we will say that you do need to have drywall behind our unit. So lots of little things come into play, not to mention all the labeling and stickers that might come along with this. So stay tuned for that upcoming training on codes, on building codes. Not necessarily, we're going to touch a little bit on the electrical code as well.
Yeah, and I will mention that if you are doing this in a utility closet that is already fully finished, you don't need to go back in and change the type of sheetrock, etc. But if it's a utility closet that is not finished, you certainly need that Type X 5/8 inch sheetrock that's there. And then of course between any living space, and we often recommend putting these batteries on the wall between the living space and the garage, and that's for heat-based reasons, right? If you get a garage that's not heated and gets quite cold, the best location is on that wall separating that. I'm actually a sheetrocker. My father was a sheetrocker, and there's a requirement already that you have a firewall between that garage and your living space. So you shouldn't need to install this. It should already be there for you. Additionally, on these parking bollards, you can do other things with the wall mountability of our battery. You can elevate that battery above 24 inches and not need to do this. Or you could even put in the parking barriers, right? For the wheel, right? The wheel catches as well. So that's another option. And you've got it here with a wheel barrier that has to be 54 inches from the ESS system to just make sure you can't bump into that as you're driving into the garage. There are locations where you don't need ballards, like for instance, the return walls right on either side of the garage doors, as long as there's not that hazard. And Daniel and I just want to point out to you as well, he's going to do a whole talk around these codes. There are some other great ones. Mayfield Renewables does them. We'll be doing it for free coming up quite soon. So stay tuned for that. The other thing I want to point out is different AHJs might have different requirements.
Yes.
And some inspectors, might be stricter than others. So if you know the code, it certainly will help you advocate for yourself and your clients. And so
a lot of the jurisdictions have a checklist, right, that you do ahead of time, and you can look through that. And of course, if you've done them before, how the inspector likes their coffee, and you can make sure you have a good relationship with them.
Sure, great point. So just going to highlight the wall base here. So if you are doing a wall type installation, you'll use a wall base, and this wall base is designed to carry the load of those batteries. There are wall brackets, and the wall brackets are here to attach the battery modules to the wall to prevent tipping. And so there are some vertical spacers as well as horizontal retainers. And I'm going to share with you some pictures of what those, a real version of what that looks like from the installations I've done. There also is the option to just mount this off the floor, put the batteries on this base that sits on the floor, and that base can get secured down to the concrete or the subfloor if you're mounting this on a wood floor, or outside if you want to put this on one of those pads. You've got pads that will set generators on. You can do the same thing outside with this. Wall mount outside, floor mount outside, but you'll need to choose one of those mounts. So we'll talk about how you assemble this. What holds the batteries together, and I'm going to use my mouse here so hopefully you can all see. As you are doing this assembly and putting the stack together, there are a couple of things to point out to you. First, the connection between each of the units, whether it's the base and the battery modules, has a screw that holds them together vertically. And so those screws go in through these tabs that are here, and that joins the bottom battery to the one above it. There's also this wall bracket we just talked about, and this wall bracket has shoulder screws that pass through it that joins the battery modules to the bracket attached to the wall to prevent tipping. We've designed this to be an earthquake-safe system. We've gone through seismic testing that shakes this battery, this assembly at a Category 9 level. And for that, we've designed a very robust attachment system to go to the wall.
And one thing we're not showing in this slide is that there are covers that cover that, and
yes,
we didn't include
there are aesthetic cover plates that'll go over it, and I will show those in a slide that's just coming up. So thanks for pointing that out. So this is how it goes together. Again, putting that wall bracket on the wall is quite a quick process, and then the controller is going to secure in the same way with those shoulder screws and those connecting screws. So here's what it looks like in person. In fact, this is me putting together a system last night. I mentioned to you that the entire video, we took a video footage of us building this, the rack, building the stack up together and completing the system. And the whole video was just over 10 minutes long. So I've done it before. It goes pretty quick. You just you locate your center mark, just draw a vertical line up, and then attach this bracket to the wall. And then you can see these battery modules slip into that bracket. You just stack them in position. And what we're doing is we've got the drill here set on a particular torque setting, and we're just tightening down those attachment screws. And what I'm doing on the right side of the screen is adding that cover plate, that vanity plate, as Daniel was mentioning earlier. So you get a nice clean aesthetic look. And here it is. The way this attaches is simply it's a slip cover, and those shoulder screws will fit inside tabs there. And so as you just slide that down into position, it takes about 5 seconds to install those side plates. They go on real quick. So thank you for mentioning that, Daniel. If you are doing an outdoor installation, I mentioned using seal tight conduit. So here there's a side panel where the wiring is done, and you can use seal tight to come through. That's the waterproof connection. What you don't see is on the other side of this plate is rubber coating, which makes a seal on the vertical side, and then there's rubber coating on the top plate that gets secured there. You're seeing the wiring bay here. These are your power terminals, these power output terminals. This is an equipment grounding screw that we've added, which is unique to this battery. We haven't done that in the past. And then these are communications. We've got an two RJ45 connections there. One will go to a gateway. The other would go to an inverter in the case of a Solarc. In the case of our system, we've got all of the community. You just need one connection, all of it to the gateway, and then the gateway will communicate with our inverter. What you see on the right is what our training wall looks like. We've got an Anderson plug coming out of that so we can connect different inverters for our training walls to it. So it's not fully complete with conduit, but that's to give us the ability to plug different units in. And you see the gateway there with communications coming into that. That gateway will power off the DC of the battery. So 48-volt input on that gateway, it allows it to power off the DC of the battery. If you are installing our inverter without the gateway, of course, if you're installing our inverter without the batteries, there is an option to just get a AC power supply for that gateway as well. So here's what the wiring looks like. This is wiring for a Solarc 15K. We come out of the batteries and go into the Solarc 15K. This provides the CAN bus communications and allows the computer on the battery system to communicate with a computer on a Solarc system. And we're going to be providing these slides to you. As mentioned, if you are doing just a direct connection to the SimpiPhi inverter, the Briggs & Stratton 6K, you would use a terminating resistor. You never want to have an open port on a CAN bus based system. That's closed loop communication always needs to have a closed system. And so there's a little terminating resistor here that lets the communications equipment know that's the end of the line. So if you're having issues with a system with communications, you always want to check to make sure that you've got the terminating resistors installed there. Whether it's an amplified battery bank or whether it's this battery bank, you need those. These dongles are included with the controller, so they are included with your system. So you'll have them when you do the install. It's not a separate purchase. All right, what is Energy Track? So Energy Track, if you're not familiar with the app, is our app that allows us to monitor, control, do over-the-air firmware updates, provide information about your system. And so we've got a QR code on the left there. So if you're interested in downloading that app, you can do so. We'll be sending this slide deck out to you. The site tab here allows you to look at your, see power coming in from your generator. Maybe if it was a grid connected system, you'd see that power as well. See power coming from your solar array through our Briggs & Stratton inverter. And then you're able to configure. You see a button there that says change configurations. I can change the settings on my system. Let's suppose I know that there's a hailstorm coming my way or windstorm that might knock some trees down. I can change my system from using that solar power that's coming in to allow the batteries to go into a different configuration in which I keep the batteries topped off, waiting, in the event that storm might cause a power outage.
Nathan.
Yeah.
So there's a really good question that came in, and rather
Sure.
than type out the answer, I really want to make sure we answer. Jim is asking, does the Solarc inverter system, right, our battery in a Solarc, require the gateway? And if it does, can you explain why? Another one, and Mitch is answering this, asking this, is I'm confused by the mention of Solarc and then seeing a Briggs 6.6 inverter in the photo. So I'll take this. The second question is,
sure,
our batteries, the 6.6, can either work with either one, right? You can use a SimpiPhi 6K inverter. It's a smaller inverter, maybe meant for a small backup, partial home backup. And then really, if you want to do a whole home backup or something larger, that's where we would position the 15K. So they're really two separate products. So Nathan, please go back. Why do we need Energy Track with the Solarc inverter? Does Solarc already have one?
Yes. Well, Solarc has their own monitoring platform, right? And the app has switched. You're probably familiar with PV Pro, which is Solarc software, which I like. I really enjoy using Solarc software. But we have individual module level monitoring of our batteries, right? That can occur through Energy Track. And that is an advantage, right? Why are we requiring it? We are requiring the gateway so that we can do over-the-air firmware updates, so that we can make sure that system stays healthy. If Solarc updates the firmware on their inverter, we need to be able to make sure that we can update the firmware on our batteries to maintain compatibility. And because of that, we do need to require that gateway. But you're getting more than just battery firmware updates with that gateway. You are getting individual battery level monitoring. And we're increasingly adding features to Energy Track as well. So it's certainly a useful piece of the full puzzle, right? And I don't think it's unique to us in needing to have those firmware updates. All equipment and technology is advancing so quickly, right, that we need to be able to be responsive.
Yeah, and just to be clear, Will is asking, you know, that app that we showed a few pages ago, that would be with our inverter. We're coming out with a kind of a separate Energy Track app where the inverter tab wouldn't necessarily be there.
Yes.
And at this time, it's not really possible to integrate the SolarArc inverter into our app, but that may change.
That may change in the future. Again, we're leaning heavily into this partnership with SolarArc because we feel like it's one of the best products out there on the market, right? So the SolarArc 15K for whole home backup is my preferred inverter. I really like the SolarArc 15K, and I really like our new batteries. I love the stackable 6.6 batteries, and they make a perfect pairing with the SolarArc. I will argue that we've designed this specifically for whole home backup and working with the SolarArc 15K with that 200 amp pass through, the ability to truly back up your whole house without installing a critical loads panel or a backed up loads panel. And so in many ways, backing up the whole home is a much simpler thing than moving loads over to a backed up loads panel and kind of choosing what's going to stay on and what doesn't. So let's highlight just for a second the SimpiPhi backup system. So this is on the smaller side of things. You know, that 15K might be, the SolarArc 15K might be too big for, for your needs. You might only want to back up a subsection of your loads. You might not have a huge solar system. And this 6 kilowatt inverter actually can continuously process 7.5 kilowatts of power. So it's got a fairly sizable solar input. And it can simultaneously use solar power together, supplemented with grid power, supplemented with battery power. And this gives you a lot of flexibility in terms of how you're using power at a lower price point, right? A smaller overall system. Single stack of batteries can power this. A stack of just one battery can power this inverter. You can double that stack capacity to 13.3 kilowatt hours if you want a little bit more storage. And of course, it utilizes our Energy Track control system as well. If you are, so we got this question a little bit earlier about what you should get in addition to a battery if you are utilizing our inverter or if you're doing an off-grid system. And one of the things that you do need to be aware of is that you should, for code reasons, have a disconnect. And I think Daniel might provide some clarification on that in his upcoming codes talk. Some jurisdictions seem to be more strict on this than others. There is, of course, a button on the batteries to disconnect the system. Whether or not that counts as your disconnect is different. It seems to be there are differing opinions on that, depending on who you talk to about the code. If you're paralleling systems, we're highlighting a couple of nice ways to parallel battery banks or even parallel the output of dual inverters. I'm showing a Polaris connector there, as well as power distribution blocks. And those power distribution blocks, those can come with covers as well. Those can be integrated into wireways. And that's a nice way to combine outputs. Let's look at a single line diagram here. And I'm going to let Daniel take us through this one. This is with a SolarArc 15K, and this is whole home backup.
Yeah, and Jeff had just asked, how do we wire from a battery stack to a SolarArc 15K to get the full inverter output since it has two 200 amp input breakers? Do we need to add overcurrent protection? So really, when we talk about the output of a SolarArc 15K, we could talk about it when it is connected to grid or perhaps a large generator. And then we could also refer to it as it is in an off-grid mode where it doesn't have grid available. So it can produce, 15,000 watts if it has both solar and a battery providing power. So when we're able to do just an off-grid system, you're not going to get 200 amps. And frankly, a lot of homes don't use 200 amps at one time. And
So I want to be clear
but
on
you
what he
can
was
surge.
asking.
Go ahead. Yeah,
I
go
just
ahead.
want to be clear on what he's asking. Was he asking about so there are dual 200 amp battery inputs.
Oh,
and
I
then
see.
there are
Yes,
200
yes.
amp, there's a 200 amp pass through from grid and 200 amp load port, on the inverter. So first thing to note,
Thank you.
as we come from grid, there is no grid breaker on the SolarArc 15K. So you will need a disconnect. And in fact, SolarArc often recommends just a manual transfer switch here, so you could even bypass the inverter if you wanted to. But you will need overcurrent protection if you were talking about the 200 amp input. You'll need a 200 amp disconnect that should be fused or breakered to provide that 200 amp power to the SolarArc 15K. On the other side of things, there are the dual 200 amp battery inputs,
which I think he was referring to.
Okay, good. So if that's the case and you've got an indoor install with freestanding battery cable, you can just use a 4-aught connection from the battery stack to the inverter and use a combiner. Briggs & Stratton is coming out with a little combiner bar that will combine a single 4-aught cable to the two dual inputs.
And
so
the also question is, do we need a battery disconnect in that case?
No, the battery disconnect is built into the SolarArc.
Thank you.
The second way to connect this would be to use dual 1-aught cables coming out of the controller on the battery. Now there's a bit more capacity to come out of the battery with dual 1-aught connections. And if you're going through conduit, because of the slower release of heat, you'll need to use those dual 1-aught connections to connect to the 15K. And you could run one of those connections to breaker number 1 and the other connection to breaker number 2. So there are two options there. Freestanding air, you can just use 4-aught cabling. If you're going through more than 24 inches of conduit, code says that you should use dual 1-aught cables coming out of our battery. And so you could double lug those 1-aughts and come to the inverter that way. Hopefully we answered your question there. I'm going to jump just because of time to this picture, which shows exactly what we were talking about. So for a single battery stack in free air, 4-aught cabling is sufficient. 4-aught cabling is rated to, I believe, 310 amps in free air. But if you're inside more than 24 inches of conduit, because you're doing an outdoor install or you've got a longer wireway, etc., you should upgrade to dual 1-aught cables. And those dual 1-aught cables, one connects to one of the breakers, and the other one can connect to the second breaker. So if you're doing 2 stacks with a SolarArc 15K, well, that's an easy answer, right? Because that SolarArc 15K has dual inputs. So for 2 stacks, you would, again, just use 2 sets of battery cables. So hopefully I got your question answered. And you don't need additional overcurrent protection for the SolarArc 15K. You do have the dual 200 amp breakers there that are monitoring, that are metering the, providing that overcurrent protection on the SolarArc side. You additionally have software protecting you on the controller side of things as well. If you're doing more than just 2 stacks of batteries, you will need to have a combiner with individual overcurrent protection on the input. So what I'm showing in the top left corner of the screen here is a 1000 amp Midnight combiner box. So let's suppose I'm doing 4 different battery stacks, right? With 4 battery stacks, what you can see on this Midnight combiner is individual battery breakers. And so you would want to have overcurrent protection on each of those breakers coming into the combiner. And then you would go out of that combiner to your inverter. There are other options, of course, for combiners. There are things like the Blue Seas combiners. You could even use power distribution blocks as combiners. These Class T fuses are available as well for a lower cost option for disconnects instead of the breakers. And those can be surface mounted inside the wireways. We're also highlighting, for smaller systems, the Midnight combiners. You can get up to 500 amps of DC current coming through the midnight DC breaker boxes. And if you are required to have a disconnect on your system, you want to have a DC disconnect on your system. These Rincon switches are rated up to 1,000 volts, and you can get these up to 1,000 amps. I'm showing one here that's a 600 amp disconnect. There is a link to that. And so if you want many of these things, I tried to link them in the presentation. So when you get these slides, you can go to those. Daniel, any questions before I move on?
We do have one question. I was going to save it to the end. Just
okay. Let me keep moving then. So if you are connecting a SolarArc 15K with our batteries, we do recommend, especially if you're using our batteries without closed loop communications built into them, we do recommend sizing those so that you have sufficient batteries to be able to provide that 12 kilowatts of power that a SolarArc can, the max power that a SolarArc can pull from the battery bank. Otherwise, you would need to derate the programming in the SolarArc inverter to the power output capacity of your bank. So if you have a bank of batteries, each one of these batteries is capable of 1.9 kilowatts. If you have a bank of 10 of these in parallel, for instance, you'd have 19 kilowatts. But if you have less than that, 5 of those, you'd be limited to about 9.5 kilowatts. And you want to program that into the inverter if you have less than 8 batteries. Can you do less than 8? Yes. But again, you want to make sure to protect the batteries and derate the SolarArc DC draw.
And that might be a good place for this question, Nathan. This was
sure.
Going back to the original talk about efficiencies. Craig's asking, SolarArc requires a charge efficiency value. I think this is one way. Also,
go ahead.
And then also, I noticed the voltage range is low, 44.8 volts. That seems pretty low for our batteries, Nathan.
Yeah, and we don't recommend doing 100% depth of discharge if you're going to be cycling every day or multiple times a day, right? We do recommend that you'll get more lifetime out of your battery. You'll get more cycles out of your battery by saving 10, 20% in that battery bank. You increase the lifetime of your battery. Let me answer the question here about what efficiency you should put in, because the efficiency of the 6.6 stack, for instance, varies depending on, Daniel, you said it earlier, depending on load, right? And depending on discharge rate. So if I discharge the batteries in the course of, let's say, their fastest discharge rate, so that I'm discharging the batteries in 1 hour and 20 minutes, I'm going to generate significantly more heat and have less efficiency. So if I was discharging the batteries very quickly, repeatedly, I would want to program that efficiency into the SolarArc inverter. So very fast charges and discharges, you should use that 96% minimum efficiency, which is listed on our batteries. But for most customers are going to be discharging these batteries at over a 4 or 5 hour period. Then the efficiency of the battery is close to 98.5%, 98%. And so my recommendation is for almost every install, 98% efficiency is accurate. Okay, so hopefully that provides a good answer. Unless you're doing very fast charges or discharges, 98% is reasonable. If you're doing very slow charges and discharges, the battery bank approaches 99% round trip efficiency. There's very little generation of heat at low currents. Point out to those on the call, if you're doing very large installations, both of these installations have, the left one has 7 12Ks, it looks like, and the right installation there has 7 15Ks. And so if you're doing very big battery banks, our Phi batteries are excellent and very easy to connect as well with bus bars. And if you need recommendations for custom bus bars, we can provide those to you as well. We've often used storm power components in the past, and we can help you if you're looking to do a large installation like this one. Let's get into the recommendations. I know we confused you by showing, talking about a SolarArc when we were showing our battery stack earlier. Daniel, can you talk us through these packages?
Yeah, so really we've kind of taken out a lot of the confusion that we caused with homeowners, talking about kilowatt hours, talking about kilowatts, and we kind of broke it down into hours of backup. And we made some assumptions knowing that the average home consumes around 1200 watts continuous. And then assuming that if you're in an essential kind of situation, you're only going to have maybe half of those loads on managed, maybe about 3/4. And then at a whole home, you're going to use all of it. So what we've done is taken that 1200 watts continuous and then divided it by the amount of kilowatt hours in the system, which would tell us how many hours of backup you can get. And I think it's important to understand that most outages in the United States aren't, minus a hurricane or an earthquake, aren't as long as people kind of realize. So these are packages well positioned. Of course, you can always lead with the whole home backup, but always have one of these smaller packages in your back pocket if the homeowner says, well, that's too much money, we don't really need that much, and be ready to pivot when necessary.
Yeah, sure. We have smaller packages. Again, this battery is perfectly suited for that whole home backup with the SolarArc 15K. I'm not seeing the Zoom menu here, Daniel, but I did just check my phone and I see that we're out of time.
Yes.
So I want to offer Q&A here. And I apologize if you have to jump. We will send out this recording to everyone who has registered for this talk. But let's go ahead and do Q&A here, even though we're over time. I'm happy to stay for a
we
few
don't
minutes.
have any open questions right now, so please put them in. I think we just have a couple more slides, and we're going to have our contact information.
Okay, so some advantages of this battery over the competition, right? We have the higher power capabilities, meaning we can provide a lot more power output than our competition for the same size battery. It's outdoor rated. We've got a wider window of temperature. We can charge down to 14. Most of our competitors cut off charging at 32 Fahrenheit. We can do
Or they
it
need
now.
heaters.
Yes, or they need heaters integrated. We've got closed loop communication with our inverter, with all of the SolarArc inverters. No wires, no dip switches here in the battery stacks. Wall mountability, you can mount on the wall, you can mount on the floor. We're very aggressive here with our pricing on this battery as well. We have a history of safety, right? I think that if there's one thing SimpiPhi batteries have been known for, it's how safe they are. And of course, we have American-based customer support. And I just want to highlight that as well. We are still recruiting for our Elite IQ program. We want to have installers that want to install with us. We provide a lot of support to you. And we're here if you want to call us, right? So if you're not part of our IQ program, we encourage you to join. We, in fact, have a promotion on this right now. Your first is SimpiPhi Briggs & Stratton ESS installation. We're giving a $1,000 bonus if that's your first system joining with us. So consider joining that IQ program. We're plugging our Power Academy here as well, where we're putting online self-paced content. So if you can't make these webinars, but you want to learn at your own pace, the Power Academy has a lot of great content, learning content, both with our generator system, our transfer switches, even business content, advice for running businesses, and our ESS systems. So our email's here on the screen. Daniel, again, I'll ask if there are questions, and if there are not, and you want to ask later, you can do those.
Jim is asking, is there a contact person for sales support?
Absolutely. So if you want to call 805-640-6700, hit extension 2, and that'll connect you immediately, right? No hold, to our sales team. If you want to reach out to Daniel and I, we can also make that connection for you. Feel free to reach out to us through that energy storage training at Basco email address that's on your screen. Thank you for attending today. All right, everyone. We hope you have a good day. Thank you for joining us. We'll see you next time.